Section 2.4, we are talking about circles. Circles are pretty interesting. The standard equation for a circle is x squared plus y squared equals r squared, where x and y are the coordinates, so the different coordinates on a circle. And r squared, r, you probably could have guessed if you've seen anything on circles, is the radius, the distance from the center of the circle to the outer edge. Now, this looks remarkably similar to something you learned in middle school, which is Pythagorean theorem. And if you recall, Pythagorean theorem is a squared plus b squared equals c squared. And it actually is very much related to that. And that may seem weird to you because what do circles and triangles have in common? And the answer is not obvious because one is curved edges and one is quite pointy. But this is actually not a coincidence that they look so much alike. And when you look at x and y and r, if I take this example I gave of a radius, I can do this. And when you look at it this way, what you will see is a nice right triangle. And I could do one from this point as well. I could make a nice right triangle, have that, oops, let's undo that, and then have right there. But what I want you to know, actually let me make that a solid line. What I want you to know is that these two triangles, all the different shapes, do have something in common. They have the same radius, right there and right there. And that radius is the C, is the hypotenuse of each of these triangles. They have the same hypotenuse. The hypotenuse equals the radius. Now, what does this have to do with the formula for a triangle being x squared, or sorry, the formula for the equation for a circle, x squared plus y squared equals radius squared? Well, I could actually go around and make a whole bunch of dots, and I could also take each of those points and make a triangle, a nice right triangle out of those points. So I could do that right there and have the same radius as the hypotenuse. I could do this one, this one right here. And what you'll notice is that all of these have a radius that is the exact same. And the two legs, the A and the B, are actually the points on these circles. One of the points measures the horizontal component, and one of those coordinates measures the vertical components. But what it does is it creates a triangle where x and y correspond. X corresponds to A, y corresponds to B, and the radius is the same as the hypotenuse. So what all of this means is simply this. The formula x squared plus y squared equals r squared is the collection of all the points that make up a nice, neat right triangle that has a radius of the circle. They all have the exact same radius, but an equation, x squared plus y squared equals r squared, is the collection of all the x-y combinations that make a nice, neat right triangle that those coordinates form a perfect circle. And so we are, in fact, talking very specifically about right triangles, but we're talking about all of them and how collectively all of those coordinates with their horizontal component and their vertical components form a perfect circle with the same radius. So it is, in fact, Pythagorean theorem. It's just a whole bunch of Pythagorean theorem. It's all the different combinations. And those combinations form a perfect circle. And so, our formula is x squared plus y squared equals radius squared. Now, in graphing, as you probably remember from high school algebra 2, transformations, not all graphs start at the origin. It's possible to have a circle that has been moved. It's possible to have a circle that's been made larger, made smaller. So the point of this is that we can add, subtract, multiply, and divide. We can do things that will change the size and location of a circle on the graph. And that leads us to this. How do we look at circles as they change location and size? It has to do with this right here. X minus h squared plus y minus k squared equals r squared. Now the size of the circle will vary as r varies. You have a very large radius, a very small radius, and everywhere in between. But the h and the k here refer to the center. Now, in the original right here, this example, the center of the circle was 0, 0. And so really what we had here is we had x minus 0 squared plus y minus 0 squared equals the radius squared. Except we don't really write minus 0. It's unnecessary. X, take away nothing, it's just x. And so what you got was there. So this still, the original does fit with this, but the original was centered at the origin. So we can move a circle around to different locations, to be centered at different locations, and we can change the size of the radius. So for an example, if I have x minus 2 squared plus y plus 3 squared equals 4, what does that circle look like when we graph it? And so we're going to sketch this out right quick and talk about what that means. Now, one thing to note, I wrote equals 4 here, but you need to know that 4 is 2 squared. So when I look at this, what can I tell about this particular point? One, it has a radius of 2 because it's r squared, so it's 2 squared, so the radius is 2. Now h and k, if you recall, is the center, and it's x minus h and y minus k. Now this may cause some confusion because this doesn't say minus anything, it says plus. This is actually y minus negative 3. It was simplified. Y minus negative 3 is similar to how 2 squared was simplified to be 4. Y plus 3 is actually y minus negative 3. So in this case, my center, the center of this circle is at the point 2, comma, negative 3. X minus h, x minus 2, so 2. Y minus negative 3, so negative 3. So if I were going to look at this equation and what it looks like to graph it, I would start by plotting my points at 2, negative 3. So I'm going to say 1, 2, negative 1, 2, 3. That is the center of my circle. Now, a radius of 2 means I'm going 2 in all directions. So I'm simply going to count 2 steps in each direction. And obviously, there are more points, but I'll be honest, I don't know exactly where 2 ends in here. It kind of ends somewhere in there. And so in graphing a circle, you graph 2 steps in every direction, and then you have creative freedom to try to ballpark the curves. So you will not be thrown under the bus if your curves are not perfect. Mine certainly are not perfect. But that is basically what you do. You find your center, and you know your radius. You plot your center. You do the radius, the distance of the radius, in up, down, left, and right, and you fill around. So that would be the circle. X minus 2 squared plus y plus 3 squared equals 4.